Welcome back, everyone. I guess if you're here now, at least undergrads, you have officially signed on for the module since I think it's too late to change now, which means it's going to get really hard from here on out because I was just going easy on you guys. That's not true. It's going to be hopefully a gradual increase in skill level. Okay, so today we're going to be talking about modules, and we'll do our first usage of actual PsychoPi, meaning not just the application PsychoPi that we've been writing our plain Python code in, but the actual collection of functions and libraries that is used to do psychological experiments in Python. So we'll get to that in just a minute. I realized as I was putting this together that really this XKCD comic that I started with the first lecture would have been more appropriate today because it's all about importing modules, and that's what we're doing today. So I used it again because I used it too early last time, and hopefully the reason this is hilarious will be clear after today. Okay, so here's today's topic, Python modules and PsychoPi 1. This is going to be a pretty gentle introduction to modules. And the good news for you guys is I find that every time I do this, the number of slides goes down. So there's only like 11 slides in today's lecture, and then counting these two so far. And the rest is just working through demos and explaining code and trying to get code working. So you guys are going to get lots of hands-on practice today. Okay, so a couple administrative topics. I will update you on your problem sets. So I think I got them for everyone that is enrolled in the class. I've only marked about half of them so far, but so far people are doing very well. One thing I will note is that no one, I looked at for this already, none of you that submitted the problem set got this secret point right, because actually if you had added up all the points on the problem set, it only added up to 3.9 points. So nobody got the secret point for answering to the last thing on there was like, let me know if you have any feedback. And if you had noticed on the feedback that there were only 3.9 points, you would have gotten the bonus 1/10 of a point. But nobody did. So that's just a lesson to you guys that I might occasionally build in tricks or, you know, things like that. I'm not going to necessarily do that again, but, you know, just to be alert and to think about things. And so it's just a 1/10 of a point, so I don't think it really matters. But that's just to let you know that I'm unpredictable. Crazy things could happen. So, you know, always look through things carefully. Okay, so that's problem set 1. I should have the rest of them marked pretty soon. But like I said, everyone is doing very well so far, which means that I can make the second one like incredibly difficult compared to that one. No, it shouldn't be too much worse, actually. So that will hopefully be up later tonight, and it'll be due, you know, the same time relative to the last one. So it'll be due on the 19th, I think, so 2 weeks after the last one. Okay, and you should be able to pretty much do everything on it after today, although, you know, sort of like last time, it might get a little bit easier after next week's lecture, but you should be able to do it all after today. Okay, any questions about problem sets or anything like that? Once I've got them all marked, we'll maybe go over them question by question and talk about a few other details. Okay, any general questions from last week or anything people are having trouble with, people don't understand so far? Okay, cool. So, so let's actually start off with a demo because last week, if you remember, we were working on that number guessing game. And I think the last version of the number guessing game that we ran was still pretty dumb, right? So it was still just kind of guessing numbers like, is it 0, is it 1, is it 2, is it 3, right? And we said that we want to try to make this number guessing game a little bit smarter. So actually, before we start talking about the true PsychoPi, let's talk a little bit more about Python and ifs, thens, and while loops and things like that, some of these core programming concepts, and show you guys how those can be used to like make your program a little bit smarter than it was before. And I know this number guessing game is a little bit boring, but what's going to happen is through the next few weeks, it's going to slowly transmogrify into an actual psychological, you know, psychophysical type task. So before your very eyes, you'll see it get a little more interesting. But for right now, we're using it because, you know, it's an easy demo. Oh, and it is worth noting, like I have in my notes down here, it may be good if you weren't already. Hopefully, like you've been saving, the demo code that we've been writing somewhere. But especially starting this week, it's good for you to like make a folder or put it on your flash drive or do something so that you can, start up again with the code that we've already written, because we will be kind of progressively building on this code for the next couple of weeks. Okay. All right. So everybody ready to do some demos? Really excited? So go ahead and start up your Psychopie. You'll notice, by the way, that when you start it up, it may ask you if you want to update, because yet another update has been released. You can just say not now, because I don't think you guys have permissions to update Psychopie anyway. So go ahead and get your Psychopie coder loaded up. If you don't already have your nice monospaced Consolas font set up, you'll want to set that up so that you get your nice your letters and everything all lining up by changing your font settings here, right? So go ahead and do that. And you see what I've got loaded up here, if you can remember all the way back to about 166 hours ago, back to last week at the end of class. This is what we finished with, right? So we had a program. We first did it with a while loop, and then we changed it to a for loop, where we're taking this variable that we called current guess. We're moving it through a range from 0 to 99. We said that there's a little bit of a bug that you hopefully all found in problem set 1, which I think you did, because it only goes from 0 to 99, not 0 to 100. But it goes up, and each time it says, is it that number, prints the current guess. You can answer Y or N, and if the answer is Y, or as Ian pointed out, we can also make it respond to the answer yes. We stop and say, I knew it, I'm awesome. All right, so everybody got that code? Everybody remember this code? So if you don't have access to that code that we typed out last week, that's okay, because I'm going to modify mine, but it's not that, it's only 14 lines, 4 of which or 3 of which are spaces, so should be pretty easy to recreate. So what we're going to do now is we're going to think about ways of making this algorithm smarter, okay? So we've said this the last couple of weeks. A better way to do this would be to start somewhere in the middle of our possible range, right? So if the number is 0 to 100, we could start at 50. And I think I played this with, who was it? Was it Vrush or somebody the first time? So we played this, and this is probably what you do naturally as a human being. If you say, all right, well, I'm going to guess 50 to start off with, and someone says higher. So that's not in the game right now, but we'll let the other player be able to say higher or lower now. And if the player says higher, then you're like, all right, well, maybe now I'll guess 75, right? And then maybe the person says, okay, no, it's lower than that, right? So then you say, all right, well, I'm going to go sort of halfway between 50 and 75 and guess, what did we say that was, like 62 and a half? So you'd round down maybe to 62 and say, is it 62? And they'd say higher, and so forth, right? Okay, so let's modify our code to do that. We're going to have to think about how we do this, okay? So hopefully, I'm sure you guys have been like spending days and days just mulling over these questions. But if you haven't, let's kind of think through the logic and then see if we can make our code do that thing, right? So one thing that we're going to probably want to do is we're probably going to go from a for loop back to a while loop, right? Because if we're doing this thing where we adjust our guess higher or lower, we don't know exactly how many times it's going to run, right? Because, if we say, is it 50? And they say, no, it's higher. And you say, is it 75? And someone says, yes, I was thinking of 75. Then you're done, right? You only have to do it twice. Or you might have to guess 5 or 6 times. So we're probably going to want to go from a for loop back to a while loop. So let's do this. Let's say, let's add a variable. I think we had one like this before called guess is wrong. I'm going to mix it up a little bit. I'm going to have one called guess is correct. And we're going to start out with that being false. And we'll change that to a while loop. And this is going to give me the opportunity to throw in a little something new for you, which is the word not. So we've already said that guess is correct is false, right? Which is a Boolean, if you guys remember that term, Boolean value. The word is, I don't know if I've ever printed out, the word is Boolean, right? Like that, B-O-O-L-E-A-N. Named after, I think his name is George Boole, the guy who dealt with this branch of logic as a philosopher. So, a lot of typing. So we want to start off saying that we're assuming our guess is going to be incorrect at first, and we want to keep looping as long as our guess is not correct, right? So before, what I did to simplify things is I just called the variable guess is wrong and set it to true, and then we would loop while guess is wrong was true, but it's logically equivalent to say, if we call our variable guess is correct, and to loop as long as guess is not correct. Does that make sense to everybody? So all that word not does is flip guess is correct from false to true. And you can do that, if you want to prove that to yourself, you can go into your little shell window and say, let's see, what's true? True is true. What's not true? Not true is false. What's not false? True. It's a little bit of a philosophical thing to keep going on with that, right? So how do we know what's true? Well, it's whatever is not false. Okay, so does that make sense to everybody? So that's just the word not. That's just throwing in a little bit of a bonus feature there. Okay, so we're going to loop as long as our guess is not correct. And it's sort of good if you start thinking about reading this in sort of Pythonese, right? So instead of saying, while my guess is not correct, you might just say, while not guess is correct, right? Which is the sort of way it's written. Let's get rid of this comment because this program will no longer have bugs. We won't have issues where we can't guess 100 anymore. And when we talk about the results of problem set 1, we can talk about how you'd fix that bug. And some of the stuff we can keep and some we can change, right? So we're still going to ask, is it our current guess, right? So now we've taken out the thing that defines what our current guess is. So we'll have to come up with a new way of defining what the current guess is. But we'll still print, is it whatever our current guess is? We'll still get some raw input, yes or no. So let's think about how we're going to set our current guess, right? Because this is probably very easy for you to do intuitively, but it's a little bit hard to think about how you would tell a computer to do it. So let's think about what we're going to do. Well, first of all, if you know that the minimum number is 0 and the maximum number is 100, what number are you probably going to start your guess on? All right, I heard 50, I think. Does that make sense to everybody, right? Because you would probably start in the middle. So we're probably going to start off with our current guess equal to 50, right? That makes a lot of sense. Oh, shoot, I just saved over my old file. Oh, well, don't do that. Use save as. Be smarter than me. Okay, so I'll call this number guess 3, even though I just accidentally saved it over number guess 2. Okay, so we're going to start off with our guess being 50. We're going to initialize our, when I say initialize, that means give a variable a starting value. So we're going to initialize current guess to 50 and guess is correct to false, right? And then we're going to do this loop as long as guess is not correct. So we're going to print out, is it this? Get the current guess. And we'll probably want to change this, right? Because we could break, actually. The break word works in a while loop, but a sort of more proper way for a while loop to work is that if the answer is correct, we probably want to set the condition that the while loop is based on to true, right? So we're going to want to say, well, if they say yes, then we can say the guess is correct, is true, right? And break would have still worked, actually, but it's a little bit more correct with a while loop. Because we're looping based on the fact that guess is not correct. It makes more sense to just set guess is correct to true. That's a little bit better style. All right, so we know what to do if they say yes, right? That's pretty much what we were doing before. But the real question is, what do we do if they say no? You're not correct, right? So this if statement is going to have an else statement associated with it, right? So let's do this. Let's say else. So we're assuming if they don't say y or yes, that they are saying no, right? So otherwise, else, colon, remember the colons. Well, we're now going to have to ask the person if it's higher or lower, right? Because that's what we have to do in order to figure out whether to go higher or lower. So we'll need another raw input line. And let's do something like this. Okay, now this is a little bit different, you'll see, than what we did with raw input up here. So we're kind of mixing it up a bit. So we're saying, should I guess higher or lower? And I think we've done this before, if you put a string inside the raw input, so up here, there's nothing inside the brackets or the parentheses for raw input, but here, put a string inside. And if you remember, what that's going to do is it's going to print that string before it places the cursor for you to type in your answer, right? And actually, if I want to be a really good graphical interface designer, I might add a space or two so that the person's answer is not like butting right up against the question mark. There's a little bit of a space between those. Okay, so we'll ask them whether it's higher or lower. Everybody cool with that so far? So we'll get an answer, and we'll get it in a string. And let's say that the person has to either type the word higher or the word lower, okay? So we'll have two conditions. We've already got an if statement up here, but we can have another if statement down here inside the else. So you can nest these ifs and else ifs just like you can loops. And by the way, there is a nested loop question on the problem set, so you get lots of practice with that. So we're going to say if the answer is equal to the word higher, right? So this is just like above, where we're testing to see if the answer was yes. So now we're checking to see if the answer is higher. Make sure you have your colon in there. We have to figure out to do, so let's just put a comment here, or placeholder. Do something here to adjust guess higher. And again, remember that pound sign or octothorpe or whatever you call it just indicates a comment. So that's just reminding us we need to put some code in here once we figure out what it will be. And then we can say else. Actually, let's say this. Let's say elif answer equals lower. Remember, elif is short for else if. So if it's not higher, otherwise, if it's not higher, check to see if it's the word lower. And then we'll have to do something here to adjust the guess lower, right? All right, so does that make sense to everyone so far, what we're doing basically? Now we still have some stuff we have to add in, but does the basic procedure make sense to everyone? So this code won't run yet until we figure out, well, it'll run, but it won't do anything useful until we figure out what to actually do in here. All right, so let's think through, just logically, what your thought process is when we play this game. All right, so if we play this game again, all right, who wants to be the asker in this, and I'll be the person whose number you're guessing. Who wants to be my human? Come on, don't be shy. So I'm thinking of a number between 0 and 100. Who wants to try to guess it using the algorithm we're going to use? Maybe someone in this front row, because the microphone will pick you guys up. Who wants to? Not Chang, you've already volunteered. One of you three. No? Okay, so Christine, so I'm thinking of a number between 0 and 100. Would you like to guess it?
Yeah.
Okay, what's your first guess?
Is it 50?
No, it is lower.
Okay. Is it 25?
Okay, so stop there. Now, what did you do to generate the number 25?
I divide 50 into 2.
Okay, you divided 50 into 2. Now, what if I told you the answer was higher? What would you guess if I said higher instead of lower?
I'll ask, is it 75?
Okay, so how would you get 75 in that case?
100 minus 50 divided by 2.
Okay, right. So what you're doing, mathematically speaking, right, is you're going halfway between your current guess and the boundary. Like, you know it can't be more than 100, and you know it can't be less than 0, right? So the first guess, you're going to either, you can think of it one of two ways. You can think of getting the average or the mean between your current guess and the maximum or minimum, or equivalently, you can think of as going half the distance between where you are and the maximum or minimum. Does that, everybody cool with that so far? Does that make sense? So that's what you're doing naturally. So all right, so let's say I said it was lower, and you said 25. So I'm going to tell you higher now. So what's your guess if I say higher?
That's the case. Is it 7?
Okay, wait. No, higher than 25. What'd you say?
37.
Oh, 37. I didn't hear the 37. Okay, yeah. Okay, so 37. So that's approximately halfway between 25 and 50, right? Now the question is, so you went halfway between 25 and 50, but why did you go between 25 and 50 is the question. You know what I mean?
Plus you say it's higher, right? Higher than.
Okay, I said it's higher, but why between 25 and 50?
Because before that when I guess 50, you say it's lower, so the boundary has like become 50.
Okay, yeah, that's a good way to say it. Okay, good. So you guys get this. So this is something as humans we do like very naturally. You know what I mean? Like it's very easy for you to be like higher, lower, higher, lower. And okay, so I didn't actually have a number in mind really. So let's just say you're right with 37. So congratulations. But so basically what you just said is right though. So what you have to do is when someone says higher or lower, what you have to do is you have to use that to update your idea of what the maximum or minimum value could be, right? So we have to have some idea of what our maximum and minimum values are. And then when someone says higher or lower, we have to average our current guess with the maximum or the minimum, depending on whether they say it's higher or lower. Does that make sense to everybody? Kind of seem reasonable? So let's say the current. Well, let's call it like let's call it current maximum. So the current maximum will be what we store our maximum possible value for our guess in. And of course, at the beginning of the game, it's 100, right? Because we say it's between 0 and 100. So we'll initialize that to 100, and we'll do a corresponding variable called current minimum. Sounds a little bit like Dr. Evil. Current minimum. All right, so, and we'll set the current minimum to 0, right? Because at the beginning of the game, the least you could possibly guess would be 0. Okay, now what we're going to have to do is update those according to the answer people give, right? So here, where we just had a comment to do something here to adjust the guess higher, let's do this. Let's say, well, what are we going to want to do if the answer is higher? We're going to want to, first of all, update our guess, right? Oops, current guess. So if they say it's higher, then we want to go halfway between our current guess and the current maximum, right? So again, you can do that one of two ways. You can either subtract them and add the difference divided by 2, or you can just take the average. So because it's slightly easier to type out, I'll just take the average, which is just current guess plus current maximum divided by 2, okay? So you'll notice the plus sign just adds these together. We've done a little bit of basic arithmetic, but it's worth mentioning again. The slash sign does division, right? It means divided by 2. And you'll notice I put these in parentheses or brackets, as the Brits would say, right? Because otherwise, what would have happened? Let's say I take out these brackets. What is that going to be then? Or what is that going to do something different? Yeah, yes, right? Probably because otherwise, why would I include them? Right, so it's going to follow the mathematical order of operations where division comes before addition, right? And that's not what we want. So we want to add them first and then divide them. So we want to, just like you would in algebra class, if you wanted to do the addition first, you put them in brackets or parentheses. Okay, so that's updated our current guess. But that's not the only thing that we have to update when we re-guess, right? So you guess higher. So if we're going from 50 to 75 as our guess, right? So then we're guessing 75 and we can go higher or lower from there. So does it change our estimate of our current maximum or our current minimum or both when we increase our guess higher? You know what I mean? So okay, let's say once again, I guess 50, you said no, it's higher. I guess 75. what are the two options? If I say it's higher again from 75, you're going to increase it relative to what maximum number? 100, right? So the 100 doesn't change. But if I guess 50, 75, and you say lower, then I'm going to average my 75 with a minimum of what? 50, right? So what we're going to do, now this is a bit tricky. We would have set, so what you really want to do is you want to change the value of the current minimum guess, right? And what you really want to do is, like, if you started out with it 50, if you started out guessing 50 and then went up to 75, right? You want to set your current minimum to 50, right? Which was your old version of current guess. But the tricky thing is we've just changed what current guess has, right? So we actually need to do this before we change current guess. And do current minimum equals current guess. Does that make sense to everybody why we have to do it that way? So maybe we can try a buggy run in a little bit where we don't do it that way and see if that works. But let's just do it the right way for now. Okay, does that make sense to everyone why we do these two things? So you want to update your expectation of what the range is, and you want to update your current guess with every time that someone says higher or lower. Okay? Now, the nice thing about programming is a lot of times if you have kind of a parallel structure like this, once you've figured out one thing, it's very easy to do the other thing, right? So answering lower is just the opposite process of answering higher, right? So we can pretty much copy what we did for higher, but we want to say current maximum, right? Because if they tell you it's lower, you would then want to set your maximum to 50 or whatever the current guess is, right? And then we want to update the current guess again. And this time we want to average it with the current minimum. All right, so everyone see, those should be the exact same two lines of code, except we changed minimum to maximum here and maximum to minimum here. But otherwise, they look like they're totally parallel. Okay. Anybody have questions about it? I mean, you'll probably have questions about it, but any questions about just that little bit? Okay, so you want to run this and see if it goes. So let's try this out. So let's, if you remember, you have to do that little trick where you hit the running man once and stop him just to get everything in the right folders. And then let's try an exec file, number guess 2.py. Let's see if this game works. All right, so let's say I'm thinking of, let's make it really hard. Let's make it guess 98, okay? So is it 50? No. Uh-oh. What did I do? Why did it do that? Oh, that's weird, actually. Oh, you know what? I'm dumb. I ran number guess 2 instead of number guess 3. All right, so stop that. So, sorry, that's my bug. So I ran that old version of number guess 2 that I accidentally saved over halfway through. So let's do number guess 3.py. Let's see. All right, so I'm thinking of 98. Is it 50? No. Higher? Is it 75? No. Higher? Is it 87? No. Higher? Is it 93? No. Higher? Is it 96? No. Higher? Is it 98? Yes. Okay, great. All right, so then if we wanted to try one where we have to go higher and lower, let's try guessing like 67. So let's run it again. Number guess 3.py. All right, so we're trying to guess 67. Is it 50? No. Higher. 75? No. Lower. Oh, look, it did the right thing. So 62? No. Higher. What did I say? 67? Is it 68? No. Lower. Is it 65? No. Higher. 66? No. Higher. 67? Yes. Okay, great. I am awesome. All right, so are people running into issues? Do we need to take a debugging break? All right, so this was a good example where Yiman just had a syntax error supposedly on what, like line 4, which is just print OK. But it's because actually there was a, what was it, a parentheses or something that was not closed off up here. So sometimes Python can get a few lines off when it tells you where your syntax error is if you like make an error on one line, but it doesn't figure out that it's got a problem until a couple lines later. So sometimes you have to look a little bit before, usually a little bit before, maybe a little bit after, to see where your error is. Yeah, so this script still does have a bug of sorts that it won't ever guess 100, but it's probably not worth fixing at the moment. It can guess 0, but that's due to rounding issues, yeah. Here's one thing. What did you guys notice? If we go back to like when it was guessing. So let's run it once more and pay attention to what it does here. What's this one called? Number guess 3.py. So if you notice, let's say I'm thinking of a number like 60. Well, 60 is fine. So is it 50? No. Higher. Is it 75? No. Lower. What's halfway between 50 and 75? 62.5, right? Yeah. Yeah. Now it guesses 62. Why is that? Because we said current guess equals current guess plus the maximum or minimum. So I'm just going to say yes to quit it. We just said to add the two together and divide them by 2. Why did it say 62 and not 62 and a half? Well, if you want, you can find out, right? So what's 50 plus 75? Well, that's 125. That's right, right? What's 50 plus 75 divided by 2? Well, that's not right. So what do you think is going on here? Does anybody have an idea? Anybody have thoughts? Well, what if I complicate the story by saying this? Why is that now 62.5? What's the difference between 2 and 2.0? Okay, so one has, well, yeah, like, so they're numerically the same thing, but one has a decimal point and a 0 in it, right, and the other one doesn't. So one thing worth remembering is that when we first defined current maximum and current minimum and current guess, all of these things, we defined them as integers, okay? So we wrote them as whole numbers, 100, 0, or 50. So what we basically told Python, although we didn't say this explicitly, but what we suggested to Python is that these are integer values, they're not fractional values, okay? And what happens in Python is if you do math with an integer value, it assumes that you want an integer value as output, okay? So if you do something like 50 the integer plus 75 the integer divided by 2 the integer, what it does, you'll notice it doesn't round, right? Because if you round, it would probably round up. Or if you want to see that for sure, you could do something like 2 divided by 3, right? Well, according to this, 2 divided by 3 is 0 instead of 0.6666. Oh, that's weird. 3. Some rounding issues. But 2 divided by 3 is 0. So what it basically does is, if you divide two integers, it throws away the fractional part, okay? Now in this case, that's actually good, right? Because we don't want to deal with fractions. We're fine if it just rounds down every time. But that's something worth keeping in mind, right? Okay. So anybody else have any questions about how any of this stuff is working? Does that make sense to everyone? Another thing worth doing is actually, do we test the case where, let's run it one more time, and just see, because another thing that you always want to be thinking about when you're programming is, you know, it's nice if things go the way you expect, but it's also nice if you build your program so that it will do something reasonable if things are not correct. So let's say, no, it's not 50. Should I guess higher or lower? Never mind, I don't want to play anymore. It just asks, so why does it do that? Anybody have an idea? So it just asks again, it's like, I'm going to ignore you. I am just going to ask if it's 50 again. So anybody see why that is? All right, so what does it do? This is where we have to like be the computer, all right? So like sort of put your mind in there. So let's step through the logic, right? So we asked, is it 50? Printed the current guess, got some input. If the answer was yes, we would have stopped and said, okay, we win, right? Otherwise, so I didn't say yes. I said, never mind, I don't want to play anymore. So we go down here, ask, is it higher? Or sorry, I said no first, and then I said, no, I don't want to play anymore here, right? So is the answer equal to higher? No, right? Because I don't want to play anymore is not equal to higher. So it says, all right, I'm not going to do these things that I do if the answer is higher. Otherwise, I'm going to check and see if the answer is lower. Is the answer lower? All right, so what does it do if neither of those is true? It just doesn't have anything to do, right? Because we didn't include a condition, because we could add another condition down here if we really want. So let me just quit this. We could have said something like else. So in all other cases, you could just say something like, answer the question. And that would sort of tell someone, that they didn't give good output, right? But otherwise, what it would have done is just nothing. And what that means is that the state of the program wouldn't have really changed at all because we didn't do anything that would cause it to update the current minimum, current maximum, or the current guess. So all of those just stay the same and it asks again, right? So, if we did want to put in some basic handling for if the user does something unexpected, this should work. So, all right, is it 50? No. Should I guess higher or lower? Screw you, program. Answer the question. All right, and then it starts over with, is it 50? So it does the same thing. It just gives me a gentle reminder that I should, actually do what it wants to do. Okay. We're still not handling it particularly well up here, right? Because we're only checking to see if the answer is yes, and otherwise we're assuming it's no. But, this is good enough for demo purposes, I think. Okay, so any questions about any of that? All right, so let's maybe switch back to the talk and talk about actual PsychoPi stuff, and then we'll maybe take a little break before we do the real PsychoPi demo. So let's talk a little bit about, actually we've got one really short demo, so maybe we'll do the really short demo and then take a break. Okay, so let's talk a little bit about what a module is. So as you've already seen, Python has a bunch of built-in functions, right? So for example, we've already used the functions printf, sorry, printf is a C function, it's just called print. So you've seen the functions print and raw input, right? So these are sort of basic Python functions. You can always access them. But sometimes you want to do things that aren't in the basic Python language, right? That aren't provided for by the basic Python functions. And you can do this by downloading or making or using modules, right? And you can think of modules as being kind of like expansion packs in a game. So, if you have Rock Band, you can buy like an extra disc of more Rock Band tracks. Or if you're somebody that plays World of Warcraft, I don't, but I'm told that you can buy these expansion packs. Or you've probably all played a game on like your iPhone or your Android phone where, you're playing a cool game, but then they want you to buy all these expansion packs and like upgrade your abilities, right? Or like, I'm told you can do this in Farmville 2 or whatever these Facebook games are that, it's like downloadable content or in-app purchases or something like that where they say, well, all right, if you get this other thing, then you can do all this other stuff that's not in the basic game, right? So Python modules are kind of like that, except, of course, it's not as fun as, new Rock Band tracks, and they're usually free. I mean, the Python language is free, so usually the expansions are free as well. So you can think of it kind of that way. It's just like a little something that you can add on to the basic package that like expands what you can do. Okay, so there's a few different types of modules. There are actually some modules that are built into a typical Python installation, but you can't they're not enabled by default. So it's very, like if you have Python on your computer, you can access them, but you have to tell Python, I want to access these. And then another version is third-party modules. So this is written by other programming groups that are outside the main Python language team. So you have to like go to their website and download their modules, and then you can use them. And of course, you can also write and distribute your own, but we won't do that because we're lazy in this class, and we just want to work off of other people's work and not have to like do our own from scratch. So one thing that you've already used that is actually a collection of third-party modules is PsychoPi itself, right? So in its heart, PsychoPi really is just a collection of modules. So if you remember back to our first day with all the stuff that we talked about that will gradually make more sense as time goes on, the PsychoPi installer is actually installing basically three things. So one of them is the Python language itself, if it's not already installed on your system. One is the PsychoPi code libraries or modules, which we'll talk about more today. And one is that basic graphical interface or the application that you get when you double-click the icon, right? Which just gives you a place to code and run your code. Now, what's worth noting is that PsychoPi itself is not even written from scratch. So PsychoPi itself is also building on other modules. So there are these modules called things like Piglet and Pygame, and these do things like give you functions to like draw things on the screen. Pygame especially has functions for like drawing stimuli really quickly, like you would if you were doing like a 3D game or something like that. Piglet is more for drawing like the windows and the buttons and stuff of that sort. So what you can do with modules is very quickly you can say, all right, well, somebody's already written some very nice functions for like drawing a window on the screen, so I don't have to spend a lot of time making my own function for drawing windows. I just have to download their module and call a function in their module that makes a window, and just give it a few basic parameters like how big the window is and if it has buttons and so forth. And actually, it's worth noting that this Python application that you run and you use the builder view to like construct your experiment or use the coder view to type your code in, that is actually, most of it is a Python script itself, which uses those modules to display its interface, right? So everything is built on these modules. And the idea here is that you really want to, as much as possible, when you're doing a high-level thing like making a psychology experiment, as much as possible you want to just build off of other people's hard work as much as you can and like reuse code they've already written, right? Because there's no sense in writing it twice if somebody else has already done some of the work for you. And this is like a good general lesson. Like you guys will find, hopefully, if you continue with this stuff, that this job of programming is going to get easier and easier as time goes on because you're going to also be able to reuse your own code, right? So you may not be able, or you may not be writing modules of your own in this class, but you'll very quickly find that like, if you have a new task to do, you might be able to adapt some old code or like copy and paste bits of old code and so forth, right? Because you want to, as much as possible, not do the same work twice. So modules are about doing that in a very specific way where somebody is nice enough to like come up with a bunch of good ways of doing things and then give them away for free. And then people like us just mooch off of that and use it to make our little psychology programs. Okay. So that's worth noting. And one little like anecdote I'll tell you, or like thing I'll tell you is like when you first start coding anything new, even if you kind of know what you're doing. So like about a year ago when I was procrastinating from writing my PhD thesis, I picked up a book on programming like iPhone applications, and I was like, this will be a fun thing to do in my spare time when I should be writing my thesis. And sometimes you spend like 3 hours trying to write one line of code because really like a lot of writing code is not like the actual writing part, it's looking up how things work so that you can write that one line, or like Googling around to find someone else that's already done this and seeing how they do it, right? So things can be really slow the first time through, but then once you've done it, you can just sort of copy the last way you did it and adapt it, right? So, as time goes on, like your coding gets faster and faster because, the thing that takes a long time is not so much the writing of the code, but like figuring out how things work. And once you've figured it out once, you can always copy from yourself. Okay. So anyway, that's the like point of modules. Is everybody excited about seeing a module in action? So we're going to try, this is going to be our last demo without using any actual PsychoPi functions. So we're going to try to add a basic Python module to our number guessing game. And then what we're going to do after the break is do it using PsychoPi functions instead, okay? So the only catch is, in the process of adding in this module, we're going to make our number guessing algorithm really stupid once again. So we're going to take this nice, efficient algorithm and make it really dumb. But we're going to do it using a module. So let's call this, I'll just call this number guess 4.pi. All right, so all that nice code that I just made, we're going to get rid of a lot of it, right? So let's get rid of all this smart stuff about current maximum and current minimum and trying to guess higher or lower. You know, we're not even going to let the person guess higher or lower because we're going to do something so stupid. We're just going to have it pick a random number every single time and guess a random number on every trial, okay? Which is, you know, that's one way to do this number guessing game. It's not really the best one. So we can delete a lot of that code we had before that was all about smart ways of guessing. And say, all right, well, we'll still have it say, I want you to think of a number between 0 and 100. And when you have one, press enter. That's still the same. And say, OK, I'm going to try to guess it now. But now what we really want to do is we want to probably start off with our first guess being, let's just put a comment here to remind ourselves, just guess some random number, right, is going to be our basic algorithm. We'll have to plug in some real code to do that in a minute. And then, you know, the logic of the program will be, all right, print, is it this guess? Get an answer. If it's yes, we'll say guess is correct is true. Otherwise, current guess equals some random number again, right? And we'll just keep guessing random numbers until we luck onto it. Okay, this is a terrible way to play this game, right? But it's an easy way to show you how to do a module. Okay, so what we want is we want a function that generates a random integer, right? Basically what we want is a random number between 0 and 100. So the way we do that is there's a module in Python that's called random, okay? And you don't have access to it by default. So the function we're actually going to use is called random.randint, and we'll explain what the dots and stuff are about now. But if I try to put that in, it'll say, like, the name random is not defined. What that basically means is we haven't told Python we want to use this random module yet. So what we do is type import random. Okay? So if you type import random, what that tells Python is, I'm looking for a module named random. Go and find that, which, you know, is going to be in somewhere within the Python directory that you've installed. So it says, all right, I'm telling you, I've installed a module called random, or whoever installed my Python for me installed a module called random. Go and look for that, and I want access to that module, right? So when that happens, when you've done the import random, then what we can do is we can use this function called random.randint. So it's a random integer. And again, we'll talk more about functions later, why we're doing it exactly this way. But we're going to put some brackets or parentheses there, and we're going to put 0, 100. And what you're basically doing is you're taking this function in the random module called randint, and you're saying, I want a number between 0 and 100, including 0 and 100. Okay, so that's exactly what we want to do. And then we want to probably copy that, or just retype it, and put it in here as well, where we're getting a random number, right? So we're just going to get a random number between 0 and 100, guess it. If it's not right, get another one, guess it again. You know, this means we could guess the same number 20 times. We could guess 1,000 times based on, you know, just how lucky we get. But eventually, in theory, we'll get the right answer. All right, so you guys want to try this and see if it works? So exec file, number guess. What are we up to? 4.pi. Okay, so let's say I'm going to think of 45. Is it 48? No. Is it 66? No. Is it 68? No. Is it 28? No. Is it 100? No. Is it 65? No. Is it 4? No. Is it 25? No. Is it 51? No. Is it 7? No. Is it 20? No. Is it 42? What did I say it was? 48? I don't know. All right, so this could go on for a while, right? But look, it guessed 100, it guessed 0, so it's got our range right at least. So it doesn't have that bug that the other versions had. Oh, so close. If only this algorithm was smarter and didn't know it was so close. All right, But you can see those are clearly random numbers, right? And it's guessing some of them over and over again. I still haven't seen 48. All right. Let's just tell it it's 18, so it'll give up. All right. So that's the random module, right? So once we've imported the random module, basically what we're saying is we can access this function now called randint, which is a part of the random module. So when we say random.randint, what that's really saying is I would like to use this function called randint, which is a part of the random module, okay? So that's how we refer to it, because there could be some other module, called like my way better random number generator, and that might also have a function called randint. So it's like saying, like my name is Matt Johnson. I am the function Matt of the Johnson module, kind of, in a way, right? So my family is called Johnson, but I am the particular instance called Matt, right? So it's sort of like your family name and your personal reference, or saying that this is the School of Psychology within University of Nottingham, Malaysia campus, right? So sort of random is the general thing, and then randint is the particular thing you want to refer to, and you would do that by doing random.randint and then the range. All right, does that make sense to everybody? So you've now imported your first module. So let's take a break. So let's start up again. So everyone hopefully has now successfully imported their first module, right? So, the word import kind of makes sense, right? Because like when you import a product, you take it in from outside so that you can use it in your country, right? So this is the same kind of idea. So you're taking some module that's outside the current range of things you can access, and you are importing it so that now you can use it, right? So that's the idea. So we've now imported random, which is not a PsychoPi module. It's just a built-in Python module. But our next step now is going to be going on to import some PsychoPi modules. So let's talk about that for just a minute, then we'll do our last demo here, which will, I think, take us the rest of the time today. Okay, so here's the introduction to PsychoPi part. So basically, like we said, PsychoPi is mostly just a collection of modules. And you can use them all together, you can use just one of them, you can use 3 of them, you can use however many you want. So you can use them all together or each by themselves. So one that we'll be working with a lot is called core, and that's just the core features, the most important, key features that don't fit into any particular category. Okay, so we'll be using the core module a lot. We'll also be using the event module quite a bit. So that's event in sort of computer speak means usually a keyboard press, a mouse button press, or something like that. So an event in sort of the computer world is like when the user does something to interact with you, right? Either by pressing the keyboard or by doing something with the mouse. There's one called sound. There's one called visual. I did not put a description down because I think you guys can figure that out, what sound and visual do. And there's a bunch more, notably lots of different modules for working with different types of hardware, such as joysticks, things plugged into your parallel port, and notably there's even a module for EGI branded EEG equipment. So if you want to use Psychopie to control the EEG setup here next door, you can do that too. And personally, I still have not figured out how that works, but I'm hoping to do that soon so that we can use it for that. Okay, and in the weeks to come, we will actually be looking, like some of the subsequent weeks, we'll be looking specifically for a long time at things like keyboard and mouse events, how to do sophisticated sound stuff, how to do sophisticated visual stuff. So we'll kind of have at least 1 week where we play with each of these modules, but we'll also just kind of be bringing things in from each of these modules as we get to it. Okay, so today we're going to use just a little bit of the visual and event modules just to get you a little bit of a feel for PsychoPi. Like I said, we'll explore them more fully later. And yeah, like the next few, I anticipated what I was going to say. So yeah, the next few lectures will focus each on what some of the key Python modules do. And at the same time, we'll kind of keep building on your knowledge of the Python language itself. So we've only introduced you to a little bit of what the Python language can actually do. But as time goes on, we'll kind of give you a little bit of what PsychoPi can do and a little bit of like slightly more sophisticated Python language usage and try to like work them both in at the same time. Okay, so the good news is we are now on to the third demo, which means we are finally going to stop having to deal with that shell window and typing in text responses. We can finally stop having to do that little trick where you click the running man and then stop to get everything in the right folder and then have to type exec file. Now we're just going to actually be able to click the running man and have the script run as God intended directly. So that's good. Because what we're going to do from now on, except a little bit in the problem set, but from now on in class, we're going to draw all of our stimuli on screen ourselves using PsychoPi instead of typing things into that text terminal. And we're also going to handle our very own key press events. Okay, so that's pretty exciting. So that's the good news. The bad news is we're still using our dumb random algorithm for the number guessing game as our example because we're not quite ready to start drawing like crazy visual stimuli and stuff. That comes later. But for now, we're just going to draw some text and handle a few basic keyboard responses. Okay? So everybody ready to give that a try? All right, so there's going to be a lot more code in this than previously. We have 38 lines of code, which is a lot. Actually, that's kind of a lot because you know, you can do a full experiment in like 200 or 300 lines of code. So 38 is a pretty substantial amount. Okay, so what we're going to do first, I think what we're going to do is kind of what we did before, which is mostly focus on typing out the code and getting it to run, and then we'll take whatever time we have to kind of explain what we're doing, and then maybe pick up on that next time if we run out of time. So once again, I'm going to make a copy of this, and I'm going to call this, to differentiate it from the others, let's call this, oops, Psychopie. Psychopie number guess or something like that. You can call it whatever you want. Okay, so let's think about what we can keep and what we can throw away. Well, we're going to want to throw away all these print statements, all these ugly raw input statements. We want to get rid of those and replace them with something from PsychoPi. We are still going to be using random numbers, though, so we want to keep the random module. And we're going to actually want to import 2 PsychoPi modules, like I said. And what we can actually do is just put them in a list with this random module. So we can import psychopi.visual and psychopi.event. So the commas there just mean what they do in English, right? We're just making a list of things that we want to import. Random, comma, psychopi.visual, comma, psychopi.event. So that means, and we'll get into exactly what this means later, but we're importing a module called psychopi.visual and a module called psychopi.event. So there's not just one module for PsychoPi like there is for random. PsychoPi kind of has submodules, right? So we specifically want to import psychopi.visual and psychopi.event. So generally speaking, when you see that dot, it means, we'll explain what this means in detail more later, but it means there's a kind of hierarchy. So like visual is a bit of PsychoPi and event is a bit of PsychoPi, right? And then each of visual and event have other things within them, right? So just like random has a function called randint, psychopi.visual has other functions inside of it, and so does psychopi.event, okay? So that'll make a little bit more sense when we start to use them. But for right now, we're just importing those 3 modules. Now we're also going to have to do a couple other things with PsychoPi that we wouldn't have to do before. So one thing is we have to tell PsychoPi a few things about our what we're doing with our hardware if we want to display stimuli on the screen. So one thing is we probably want to know what our display resolution is. Okay, now this will be a little bit different for you guys than it is for me. Mine right now, because I'm running on the monitor here, is 1024 by 768. Okay, yours is probably, I think these are 1440 by 900, if I'm right. Okay, is that correct? People are nodding. So you're probably going to have here 1440, 900. If you have another number in there, what you'll find out is PsychoPi doesn't freak out. PsychoPi just says, you're lying to me and your monitor resolution is this. But we want to be well behaved and tell PsychoPi that we're running at the resolution we're actually running at. Oh, 1440 by 900, I think, is what you guys are on. Okay, so we'll see how we're going to use that in just a second. And we'll also, in a minute, what we're going to want to do is we're going to put some text up on screen, but we maybe don't want the text to run all the way to the corners of the screen. So I'm going to define a variable that I call text width. And I'm going to say, let's use the middle 800 pixels of the screen. And I'm going to put all my text in there. Because you'll see PsychoPi will automatically like put things onto the next line if they run too long and things like that, which is very nice. Now, again, this is not anything about, these names are just what I called these things. You could have called them Billy and Fred, but it makes more sense to call them what they actually are, right? So we come up with some good descriptive names. And this is something I'm going to encourage you guys to do in general, which is to put all of your critical values for your experiment at the top of your script. Because then it's very easy to go up to the top and see, like, okay, this is meant to be run on a 1024 by 768 display. The text is 800 pixels wide. And all kinds of other things, like how many trials there are and things like that. So what I typically do and what I encourage you guys to do is to have like a little section at the top. You could even, label it as something like, important values for my experiment, or something like that. I mean, you would probably not say exactly that in your real script, but, you would say something like, maybe would say instead, you would just say something like, settings or something like that, right? And then you could have another comment that says, no user settings below this line or something like that. This line, real code starts here, right? Because it's kind of nice to get a separation between lines of code that really are just kind of setting up things that might change in your experiment versus the actual code. Does that kind of make sense to everybody? It'll make more and more sense, hopefully, as time goes on. Okay, so now what we're going to do is we are going to do our very first line of real PsychoPi code. So the first thing you generally have to do when you start an experiment is make a window, right? So what we're going to do is we're going to create a variable called, let's call it my window to make it a little more clear. And let's not worry, we'll talk more about this later. Let's not worry about exactly what my window is, right? Because text width is an integer. Display resolution is kind of you can think of it as kind of a list of two integers. But let's not talk about what my window is. That's going to blow your minds a little bit right now. So let's just assume we're going to create something called my window. And it's going to be created with something called PsychoPi, PsychoPi.visual.capital window. And again, we're going to talk more about how functions work and all this stuff. So it's going to be clearer why we do these things in future weeks. But we're going to, basically this psychopie.visual.window is a function within the psychopie.visual module. And in order for it, it's going to create a new window, and it's going to let us refer to that window with the name my window. But in order to create it, we need to tell it various things about the window. So we're going to tell it what our display resolution is. And we're going to tell it a couple other things. So we're actually going to tell it, and again, you can just copy this for now. This will make more and more sense as we go back and talk about these concepts. It's full SCR with a capital S equals true. Basically what that's going to tell the function is that the function has a variable inside it called full screen or full script. And we're going to set that to true. You know what? Oh, I totally lied to you. I believe the S is a little s, not an uppercase S. I guess that's not too much of a lie. Okay, so full screen is going to be true because we want, usually when we're doing an experiment, we want a full screen window. So we want our experiment to take over the screen. We're going to tell it what units our stimuli are in. So we could, if we wanted to, set our units to be like centimeters wide or visual angle degrees or something like that. But to keep things simple, because we're all on different size monitors and things like that, we're just going to set the units to pix, which is pixels. So we're going to tell it our units are pixels. And there's one other thing that we're going to put in here, which we won't worry too much about right now. But we're going to put in something called allowed GUI, and we're going to set that to false, okay? So just a lot of this you're going to have to take on faith for right now, but just take on faith that this is going to create a window. It's going to create a window the same size as our entire monitor, and we're, just to be safe, we're going to tell it it's a full screen window, and that we're referring to things in units of pixels, and there's a couple other things that we're doing that we won't get into right now, okay? All right, So when that line runs, it'll create a window. The next thing we'll want to do, we want to still tell the user to think of a number between 0 and 100, but we want to get rid of this stupid print statement. That's terrible. So let's get rid of that. So let's instead, we're going to want to make basically a text variable, right? Or in other words, we're going to want to, in PsychoPi, we can't just make a string and say, draw the string. We actually have to make kind of a string or a text object, basically something that tells PsychoPi about a chunk of text. And again, I'm being a little bit loose because I don't want to tell you right now what my window really is. And similarly, I don't really want to tell you exactly what my text is going to be. But just take my word for it that it refers to a bunch of information describing some text, okay? And now we're going to use a different, psychopie.visual, a different part of psychopie.visual called text stem, okay? Big T, big S. And we're going to also give it some information the way that we gave the window function some information. And so we're going to tell it, first of all, what window we want to display the text on, because that's important. We could have multiple windows. So we're going to tell it what window it goes on. We're going to tell it what the text is. So it has a thing called text. And that text will actually be basically what we were printing with the print statement before. So I'm going to cut that out. Say, I want you to think of a number between 0 and 100. Get rid of that print statement. And then I'm going to do something a little tricky. I'm going to have a \n and a \n. You'll find out what that means later. And then I'll put that second line in there as well. Okay, so let me close it off, and then I know it's scrolling off so you guys can't see it all. So let's get rid of it. So we're going to get rid of that raw input line too. So what I'm going to do is say my text equals basically psychopie.visual.textStem will create a new variable that represents the information about this block of text. And it's going to be shown on my window. Oh, so, sorry. I called it my win originally, and then I changed it to my window. So let's call it my window. Sorry. And then we want to tell it that the text of it is, or the string that defines that text is, I want you to think of a number between 0 and 100. We've got these mysterious \n that I will explain later. And then when you have one, press enter to continue in your string, and make sure you close it off with a bracket or parentheses, whatever you'd like to call that. All right, and that's going to create a representation. Oh, you know what? Sorry, I totally lied again. We're not done yet. We want to tell it a few more things about our text before we close that parentheses. Okay, so we also want to tell it what our font is, because the text could have all kinds of different fonts. So I'm going to want to use the Courier New font, because I like Courier New. You can use whatever you like if it's installed on your system. You just call it by name. So Courier New is my favorite for this kind of experiment. And you know what? I want it to be in bold. So I'm going to say bold equals true. And a couple other things. I want to define the height of the font. So I'm going to say height equals 36 is a nice height, I think, for this kind of thing. And the last thing is, remember how I said we were going to have it automatically wrap around when it gets to a new line. So we defined this text width thing as 800. So we're going to define a little thing in this function called wrap width, which is how wide the text can be before it wraps around to the next line. Oops, sorry. And it's going to be set equal to that text width thing that we already defined, right? Whoops. Okay. So does that last bit make sense to everyone? So again, what exactly all this means, we'll get to later, but basically we were telling it our font is Courier New. It is bold. Its height is 36 pixels, and it will wrap the text in the next line whenever it gets to text width. And now we could have put a number in here, but the nice thing about having a variable to define this is if we have like 10 different, if we end up with 10 different text displays in this experiment, and we decide we want to change our text width, we can just change it once up here, and then that'll automatically update everywhere else, right? So we don't have to go in and find every time we typed 800, which is why it's really nice to define all your critical values up at the top of the function here. Okay, everybody kind of got that in? So now we're going to take a big step. We're going to do my text dot draw. Again, you're going to have to take a lot of this on faith, but that's going to it's going to tell the text to draw itself, which is a little bit of a weird way to think about this. But in other words, instead of telling something to draw the text, you're telling the text to draw itself in a way. So again, we will get to all of this and why it makes sense later. And we're going to call a very mysterious function called mywindow.flip, F-L-I-P. And then we're going to do one more thing before we test this out. And we're going to call a function called psychopie.event.waitKeys. And that's a little w, a big K. And some brackets. And then what I'm going to do, because I want to keep the rest of this code around, if I want to use it, but I don't want it to actually run right now. So I'm going to do this trick, which I don't know if I've shown you guys this before, but I'm just going to put a little pound sign or an octothorpe in front of every line of code, which is cheating a little bit and telling Python, yeah, don't worry about those. Those are just my comments to myself. I just wanted to make a note that suspiciously looks a lot like Python code. Because we call that commenting out. Have I used that phrase before? So what we're doing here is I have some code that I might want to use later, but I don't want it to actually run. So I fake Python out by telling it this is just a comment, right? Because Python doesn't care about comments. I could say something like, hey, Python, you suck. And Python's not going to get mad at that because Python just totally ignores that comment as long as it's preceded on that line by a pound sign, right? So if you take out the pound sign, then Python gets angry. Well, Python encounters a syntax error because it doesn't actually know what that means. But anything that starts with that octothorpe or that sharp sign or that pound sign is just ignored, right? So that's our way of kind of keeping this around for when we want to finish playing the game, but we don't want it to run. Question.
I assume it is that there isn't a way to comment a whole lot of code.
There is actually. I wasn't going to get that far yet, but yes, if you look, so depending on your code editor and how sophisticated it is, you can also just select your code and say comment or uncomment. You guys see that up there in the edit menu? So if you want to take a whole chunk of code and make it comment itself all at once, because this is a very common thing that programmers do all the time. So you can take the whole block of code and uncomment it or comment it. Does that see everyone how I did that? So if you want to kind of temporarily invalidate a whole bunch of code, you can do it that way. Oh, did I take out? Did I accidentally delete that last line of code about how I'm awesome? I guess I did. All right, well anyway, the only thing I accidentally took out at the end was the victory line, but that's fine, it doesn't matter. Or I can just undo back to wherever I had it. Ah, there it is.
Actually, when you uncomment that chunk of code, the last line disappears.
Oh, maybe that's maybe a bug. Not in anything we're doing, but possibly in the Psychopie editor?
Yeah,
maybe it's because I didn't have... Oh, all right, so guys, never mind. Beware of the uncomment function. There might be a bug in that. All right, so yeah, watch out for that. Anyway, the answer is, Psychopie is great, but the graphical interface for Psychopie is actually really basic. So if you get to be really serious about coding, you probably want to use a different editor. So one that's, if you want to make a note of this, if you ever do a lot of code editing, Notepad, oops, if I can spell it right, Notepad++ is a really good free program that has, it does all this stuff. It'll, highlight your code as if it's Python code as long as you tell it your code. It'll let you program in a bunch of different languages. You can tell it it's Python, and it correctly interprets the text as Python and highlights it nicely in all these different colors. You can tell it it's MATLAB code. So, again, this is something, when we get into sophisticated programming world, programmers are really super anal about which code editor they actually use. But the one in Psychopie is really super basic, so there might be a few bugs, so just be careful with those. Because, until we get super advanced, I think we're just going to keep everything in the Psychopie coder to be simple. Okay, so everyone got these first, what I've got is 13 lines of code. So everyone got those, so let's see if this works. Now, like I said, hopefully now we don't have to worry about that dumb shell anymore. We can just say, running man, run. Let's see what happens. This is promising. All right, so it worked for me. Everyone want to try running your own and see if that works? So in theory, now all it's doing so far is just telling you, I'll run it again. All we've told it to do so far is put these 2 lines of text on screen, wait for a key press. Oh, you know what? Let's change that, because actually what we've literally told it to do is wait for any key press. So let's just say press any key to continue. Sometimes it's easier to change the instructions than to change the actual code. All right, so now it says I want you to think of a number between 0 and 100, so I think really hard. When I have one, I press any key to continue, and I press a key and it finishes, right? All right, so maybe take a break and see, do we have bugs and issues? Let's see how far we can get in making this thing actually guess some numbers before we go, because actually, so I know I haven't told you guys what a lot of stuff is, what a lot of this really means, but basically you can kind of tell what's happening is we're making a window, we are describing some text, we are telling the text to draw itself, we're doing this mysterious flip thing, which we'll have to wait, I think, till next time to describe what it's doing. And then we're calling this event called wait keys, which waits for a key press before it does anything else, right? So now we just have to, if we want to play the guessing game in PsychoPi, we just have to go back through and present or replace the rest of our print and input statements with PsychoPi code, right? So this is actually going to be a little bit easier now because we can kind of copy and paste a lot of what we're already doing, right? So, for example, we can kind of copy and paste this text display, this whole block of code here, these 4 lines, because the next thing we did before was print, okay, I'm going to try to guess it now, right? So we could just keep those same 4 lines of code, but replace this I want to think of a number business with, okay, I'm going to try to guess it now, right? So we can just say, okay, period. Let's maybe do those \n, which we haven't really talked about what they do, but you can probably sort of guess what they do. I am going to try to guess it now. Okay, so, whoops, sorry. So you'll see already the value of copying and pasting, and I'm going to go ahead and get rid of where I printed that before, even though it's just a comment. So, you know, it took us a little time to write those 4 lines of code earlier. It took us just a second to copy and paste the same 4 lines and change the text that we're printing. And let's see how that changes our program. Okay, I want you to think of a number between 0 and 100. Got one. All right, press any key to continue. Okay, I am going to try to guess it now. Hey, cool. We're on our way to having like a real interface, right? Okay, so let's see. We have, 14 minutes left. If we want to use the whole time, we maybe won't use the whole time, but let's see how far we can get. So now let's think about our program, right? So we do want to still guess the same way as before. We want to come up with a random number, so this part's fine. And we want to begin assuming that our current guess is not correct, right? That's still okay. And as long as our guess is not correct, now this line we're going to have to change, right? Because we don't want to use those print statements anymore. Those are lame. So we want to replace this with Psychopie asking us if it's this number, right? Now we're going to have to do a couple other funky things, which once again, I know I'm invoking a lot of voodoo right now, but take it on faith, and it will all make more sense as time goes on. Okay, so I'm going to define a new variable now called myString, and say, is it curly bracket 0 curly bracket, and then the y/n. So many things that you guys are learning right now and don't quite fully understand. And then dot format. A lot of this will make sense starting next week. Current guess. Okay. So that is just one weird looking line of gibberish. But you can kind of see the parallels to that print statement that I'm about to delete, right? You can still see that what it's probably doing is saying, is it something, y/in question mark, and it's going to plug in current guess there, right? But we're doing it in a slightly different way than we did before. And again, this will all make sense in the future why we're doing it this way now. So now we should, in theory, have a variable that includes that text. And now what we can do, we can copy this myText line again, right? Because we're going to want to make another text stimulus. But now, instead of like typing in some literal text here, we're going to tell that the text that we want to display is my string. Okay? Again, we're going to take this a little unfaith here. So we've got that, and everything else stays the same. So nice use of copy and paste again. And then we can also copy some of this stuff. So let's copy the myText.draw and the mywindow.flip. Notice we're going to have to make our indents ourselves, right, to make it all line up. So that's going to finish drawing the text on the screen. And then this time we have to do a little bit something different with our waiting on keys, right? Because now we don't want to just wait for any key press. We want to specifically get a particular key press, right? Because it really matters now whether they answer yes or no. So we don't want to just wait on any key press and not worry about what the actual result is. So we're still going to do psychopie.event.wait keys, so we can actually copy that if you don't want to type it again, or if you're worried about typos. But this time, instead of, so this sort of parallels the raw input line. We're going to say answer equals this psychopie.event.wait keys. So what we'll see is that this function can just wait for any key press and then move on. But what it can also do is it can put the result of whatever you pressed into this variable called answer. Okay? Again, I know this is a lot of voodoo all at once, but it'll make sense as time goes on. Okay, this line is complete voodoo. But just type it right now. So answer equals answer, square bracket, 0. That one's magic. We're going to have to wait to explain that one. But I want to get to the end so that you can see the magic of this. And actually, now we can kind of use some of these lines again. So if answer equals y. Now the one thing we can't do right now is we can't have them type in a whole thing, because as soon as they hit a key, it's going to go on, as you'll see. So we can only test to see if answer equals y. But we can keep that. And we can keep the else. We can keep that. And the only thing we have left to do, everything else we can kind of keep the same once we've replaced all our text display and our input getting. Is we, if we want to have our celebration at the end, we can copy our little chunk of code again here that draws something on the screen. Paste it down here and replace that with our I knew it. I am awesome. And then maybe \n, and maybe tell them press any key to exit this time, because that's a helpful thing to tell someone. We're just changing the text. And then again, we're drawing the text, doing this flip thing that I haven't explained yet, and waiting on a key press. And then, as you've seen, what happens when you get to the end of the script is that it just quits out of everything it was doing and returns you to the PsychoPi coder, right? All right. So I know you guys are probably still typing and such, but let me go ahead, because it's 3:52. Let me go ahead and try to run this. Let's just see if this works. All right, so I'm thinking of, let's say, 52. So I'm going to press a key to continue. All right, I'm going to try to guess it now. Is it 85? I'm hitting no, in. Is it 69? No. Is it 79? No. No, 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 no. No, 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 no. Oh, I think I saw it. Oh, maybe I didn't. No, 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 no. No, 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 no. All right, well, anyway, let's just say it's 27. Yes, I knew it. I'm awesome. Press any key to exit. All right. I now have, I've done my work. I have a working PsychoPi experiment of a sort, or a working PsychoPi program. So we don't use any sort of plain Python code to display text or anything. This is all using PsychoPi to display text and everything on the screen. Now, I guess with the rest of the time, we can do some debugging. Does anybody have like just general sorts of questions or things like that for posterity, for the podcast? Okay, so let's take the last, basically we're done for today, but let's take the last few minutes if you want, and we can debug this. We'll kind of start up with explaining it a bit more next time. There won't be too much of this on your problem set, but there will be a little bit asking you to adapt this code. Okay, so even if you don't understand all of it, you should kind of know, you should probably have a working version, because what I'm going to ask you to do in your problem set is to update this code to stop doing the random number guessing thing and go back to the smart number guessing where we have a maximum and minimum. So it won't really change much of the PsychoPi code, but it will require you to have a working version of this that we adapt. Okay. So any questions before we go into debug mode and break for the day? Okay. So thanks again, guys. Like I said, yay. Yay for PsychoPi, right? So now we're going to be doing serious PsychoPi from here on out.